So here's some example questions from page 14 out of your notebooklet. Okay, so the first one, a 0.15 moles per liter solution of hydrochloric acid at 25 degrees Celsius is found to have a hydronium ion concentration of 0.015 moles per liter. Calculate the amount concentration of hydroxide ions. So in this case, again, we're given the hydronium concentration. Okay, so we're just going to go Kw divided by the concentration of hydronium ions. Okay, put our numbers in, and then we get our that's hydronium. Yeah, the hydronium ion concentration, this should say hydroxide ion concentration, 6.7 times 10 to the minus 14. Okay, so calculate the amount concentration of hydronium ion in 0.25 moles per liter barium hydroxide solution. Okay, so again, we always start any of these with our equation. So in this case, we have our acid ionization. Okay, remember for strong bases, okay, they just dissociate. So we get Ba2 plus 2OH minus. Okay, so we start with that. So we're given this concentration, 0.25 moles per liter. So to find this concentration, we're just going to have to times it, 0.25 moles per liter times our required over given, so 2 moles for 1 mole. And we get 0.50 moles per liter. Okay, and so that's just using our stoich, which we learned about last year, and how to convert. Now we just need to take, now we're going to use this formula. So if we're looking for the hydronium concentration, it's going to equal the Kw divided by our hydroxide concentration. So our hydronium concentration is equal to 1.0 times 10 to the minus 14. Okay, again, there's no units here. That is our equilibrium constant. Okay, divided by 0.50 moles per liter. And so we get our hydroxide concentration is equal to 2.0 times 10 to the negative 14 moles per liter. Okay, move on to this next example here. Okay, so determine the hydronium and hydroxide ion amount concentrations, okay, in the 500 milliliters of aqueous solution for home soap making. So it contains 2.6 grams of dissolved sodium hydroxide. Okay, and so we have sodium hydroxide. Okay, that's going to turn into sodium, so Na plus and OH minus. Okay, write down what we have. So we have the mass, 2.6 grams. Okay, again, whenever we see mass, we want to find molar mass. Okay, so molar mass of that, okay, molar is 40 grams per mole. Again, we're given our volume. We want to convert that to liters, so 0.5 liters. Okay, we want to find what is this concentration. That's kind of the first thing we need to find. Okay, so we're using stoich. Okay, it's a 1-to-1 ratio. Okay, so we'll just start with our mass, 2.6 grams times 1 mole over 40 grams. That gets rid of our grams. So we have moles of this, but we want moles of this. So we're going to times it by our 1 mole over 1 mole. That cancels with that. Okay, we want moles over liters to get concentration. So we're going to go 1 over 0.500 liters. And we'll calculate our concentration of hydroxide. Okay, 0.13 moles per liter. So that's how much hydroxide we have. Okay, and then we'll just use our Kw formula. So to find hydronium, it's going to equal 1.0 times 10 to the minus 14 divided by our concentration of hydroxide, 0.13 moles per liter. So our hydronium concentration is equal to, and we have two significant digits, so 7.7 times 10 to the minus 14. So again, like with bases, which we know, like we have sodium hydroxide, a really strong base. We have a high concentration of hydroxide, a low concentration of hydronium. Again, it's opposite for any strong acid. Okay, so now last question here. Calculate the amount concentration of hydronium ions in a 0.1 mole per liter aqueous solution of ammonia that is used in a spray bottle for a window cleaning solution. So a reference states that there are 2.1% reaction of dissolved ammonia with water. So basically 2.1% of ammonia goes forward at the concentration of SATP. So first off, we have ammonia plus water, water, and that's going to produce hydronium plus hydroxide. So our concentration of ammonia equals 0.100 moles per liter. Okay, we want to know what this concentration is in order to then find the concentration of ammonia. Okay, and so it's 1:1, but only 2.1% of the reaction, so only 2.1% of this reaction actually proceeds forward. And so we have to go back to our percent of ionization equation. Okay, so our percent ionization equation equals hydroxide over the concentration of hydroxide over our initial concentration of our base times 100%. So if we want to find our concentration of hydroxide, okay, we just rearrange this formula. Okay, so we have is equal to our whatever percentage we have over 100 times the concentration of our base that we start with. Okay, so we just put our numbers in. So our concentration of hydroxide is equal to 2.1% over 100 times 0.100 moles per liter, which equals 0.0021 moles per liter. Now we put into our water ionization, so we want to find hydronium again. So it's going to equal 1.0 times 10 to the minus 14 over our concentration of hydroxide to give us our final answer for hydronium ions, which is 4. We have two significant digits, so 4.8 times 10 to the negative 12 moles per liter.